Hello students. In today's class we are going to discuss about current electricity, the basic concepts behind current electricity, quantization of charge or the current flowing through a conductor. We will be studying about electric potential, potential difference, resistance of a conductor, Ohm's law, and these are the important topics of this chapter. So let us begin with electric current. We know that first concept that we come across is charge. We know that any substance is made up of atoms. So when a substance is rubbed, it gets charged. We are not going to study here the conventional examples that were taken, that suppose glass rod is rubbed against silk or amber is rubbed against. Such conventional examples we are not going to study, but in general what we have to understand that when a substance is rubbed, there may be two cases. First, if it loses electrons, then we will have positive charge, and if it gains electrons, then we will have negative charge. So charge develops when a substance is rubbed. Suppose when you rub a dry comb against dry hair, you will find that comb gets charged and it attracts small pieces of paper. Means the comb is having certain charge. Now, so there are two kinds of charges. There are two kinds of charges. First one positive and second one is negative. These are two kinds of charges. And what is the behavior of charges, nature of charges? Nature of charges. First one, like charges repel each other. Means plus, if comes in close or comes in contact with plus, then you will find here repulsion, or if minus comes near minus charge body, then also you will find there is a repulsion. But second type, unlike charges attract each other. Means when plus charged body comes in close contact with negative charge, there you will find that there is attraction. So these are basic things, very basic things about charges. Now we will be talking about current, electricity. So let us define now current, electric current, what it is. conductor, let us say, and when it is not connected, then free electrons are in random motion, means they are not in a fixed direction. But when that same conductor, if it is connected to a source of current, then what do we find? There you will find electrons will start moving in one particular direction. That is basically from higher potential region, that is negative, towards lower potential region, it will start moving. The electrons will start moving. So, what is current then? First basic thing that you have to understand that electrons are the charge carriers. Electrons are the charge carriers. Electrons carry the charge. Means, then what is current? Current. It is the rate of flow of charge through a conductor. So according to the definition, we can say current is quantity of charge moved in a given time. Quantity of charge moved, where I means current, Q means it is quantity of charge, and T stands for time. Okay. Now, what could be the SI unit for current? SI unit of current is ampere. Since it is after scientist's name, so if we write full ampere, then we have to start with a small letter A, or else you can write capital A. Now, if you are asked to define, if you are asked to define 1 ampere, how will you define? 1 ampere is the flow of 1 coulomb charge through a conductor in 1 second, or you can write in short, 1A is 1 coulomb by 1 second. In short, you can write this way. Now, if you wish to measure the quantity of current flowing through a conductor, which device we shall use, that, and what are its properties, how is it connected in a circuit, that is also very important. So let us study now that. We are going to study now about ammeter. Ammeter. When you see an electric circuit, let us say this one is an electric bulb, then ammeter has to connect it in series. This is switch. Let us say it is in on position. Okay, this is closed circuit, or we can say a simple circuit, a simple electric circuit. you find here ammeter. So how it is connected? Ammeter definition: it is a device used to measure current flowing through a circuit. Okay. Some other properties about ammeter that you should know: that it has very low resistance, so that it can measure negligible current through circuit. This is also very important line that you should understand, that it has very low resistance. Another one, an ammeter is always connected in series, so that every electron is measured. Means whatever the electrons are flowing, all such electrons will get measured, that will get counted, so we will get the result, accurate result. Okay. Now we have another important topic, that is quantization of charge. Quantization of charge means actually quantity of charge. Quantity of charge flowing through a conductor. So Q is equal to NE. This is the formula that we can use to find the quantity of charge flowing through a conductor, where Q means quantity of charge, N means number of particles, basically electrons, then E, that is 1.6 into 10 to the power minus 19 coulomb, that is the charge of one electron. So if you are asked to calculate, you can, I'll just give you a question where you can solve. Question: calculate the number of electrons carrying 1 coulomb of charge. Okay, for your information, when you calculate, you may get. So answer, you will calculate Q is equals to NE and N is equals to Q by E. So in formula, if you put, you will get N is equals to Q, that is 1 coulomb, divided by 1.6 into 10 to the power minus 19 coulomb. So when you divide, whatever you get the answer, you may check yourself afterwards. So that you will get. Okay. Now we have some other topics, basically electric potential. This one we will be discussing now. So you can continue with your calculations. Electric potential. imagine that this one is an electric field and there is a point at infinite distance, we don't know, away from the electric field, and there is a test charge, and this charge has to be carried, and in doing so some amount of work is getting done. So that is electric potential. How we will define? Suppose this one is the point P and this one is electric field. This one is electric field where the charge can be experienced, the effect of charge can be experienced. So electric potential at a point P, let us say, is defined as the amount of work done in moving a unit positive charge from infinity to that point. So electric potential V is the amount of work done in moving a charge. That is what it is. So this one SI unit is volt. Okay. If you are asked to define 1 volt, then how will you define? 1 volt of electric potential means if 1 joule of work done in moving 1 coulomb of charge. Now, related to this, we have a topic, potential difference. This is very, very important. Potential difference. Suppose you must have seen, let me say, a cell. It has positive and it has negative. So, if the electron has to be carried, and in doing so, how much work is getting done, that will give us the amount of potential difference. Means negative terminal may have some higher potential, positive terminal may have some lower potential. So difference between these potentials, we call it potential difference. So potential difference means potential difference is the amount of work done, in moving a unit positive charge from one point to another. In an electric field. So, if I say that electrons are flowing from point A to point B, means this one has higher potential and this one has lower potential. So, potential at A minus potential at B will be given by amount of work done in moving unit positive charge. Okay. Now, we should know that how you will calculate potential difference. Now SI unit of potential difference is volt. And if you are asked to define 1 volt, then you can say that 1 volt of potential difference between two points in an electric field is when 1 joule of work is done in carrying 1 coulomb of charge. That is 1 volt. Now we have to understand the device used to measure potential difference in an electric field. Voltmeter. Voltmeter, it is a device used to measure potential difference between 2 points. In an electric field. So, since it has very high resistance, let me say between these 2 points, then voltmeter will be connected in parallel to the resistor. So, voltmeter has high resistance and hence always connected in parallel to the resistor. In other words, you have to understand that how much resistance this one is offering to the flow of charge can only be measured if it is in parallel. Means between these 2 points we are there to find that how much electrons or with what magnitude the electron flow is opposed. So that's in that sense potential difference is measured. Okay. Anyway, next topic that we have is direction of electric current. This concept is also useful. Direction of electric current. Very simple, you have to understand that conventional concept, conventional direction or concept, what we have. Let us imagine that Benjamin Franklin was flying kite. What did he find? He found that there was thundering, so electric spark he could get. So he felt that the current always flows from higher potential to lower potential, and for him higher potential means positive, lower potential means negative, because in those days electrons were not discovered. So he just said that current flows from positive to negative. I hope you have got it. So the conventional direction in an electric circuit, you would always find that it is from positive and it goes towards negative. This is conventional direction. This figure shows conventional current Now, modern concept, what it says? Modern concept. It says that electrons carry the charge. Electrons carry the charge. Therefore, in terms of electrons, in terms of electron flow, if you see, then I would say this is negative terminal, electrons will flow towards positive terminal. So this is direction of current in terms of flow of electrons. Therefore, this is modern concept where we say electrons, they carry the charge, so the direction of current should be negative to positive. Or we can say that this is actual direction of current. So, to respect Benjamin Franklin, even today we saw in an electric circuit the direction of the flow of current from positive to negative. This thing you have to keep in mind. Okay. We have another short important topic. We will discuss this now. That is Ohm's law. This Ohm's law, it is useful to measure resistance of a wire in a circuit, in a closed circuit. Closed circuit means on wala position. Okay. Suppose there is a resistor here R, voltmeter is connected, we have ammeter here, we have switch, source of current, and we have variable resistor. Now, this is the basic circuit diagram you have to understand, and when you connect in the laboratory to verify Ohm's law, or to verify whether the conductor you have taken is ohmic, or means whether it obeys Ohm's law or not. So, in that sense, when the electrons and the current is flowing, what does the Ohm's law say? Let us say the statement what it says. At constant temperature, the current flowing through a conductor is directly proportional to the potential difference applied across its ends. Mathematically, if you wish to know what it says, then that V is directly proportional to I, or V is directly proportional to IR. So we can write V is equals to IR, where V means potential difference, I means it is current, and R is resistance. and this resistance is actually considered constant for a conductor. Constant for a conductor means when other conditions are constant, like length of the wire, thickness of the wire, temperature is not changing, material has to be fixed. In that sense, resistance is constant. So since it is constant, how we will write? We can write V is equals to IR, so V upon I by R, or V, this one is constant. So this formula or this one is very useful in solving numerical problems. Other concepts of resistance and other things we will be talking about in our next class. So this class we have talked about charges, current, electric potential, potential difference, and in short, Ohm's law. Graphically, if you wish to represent Ohm's law, verify, how will you verify? Suppose V you will take in y-axis and I in x-axis, then you will draw a graph. If the graph is straight, means it is obeying Ohm's law, and if you want to get resistance, then change in V by change in I, you will get a resistance. So to get resistance, you will have to find out, let me write the point slope of AB. Slope of AB, that is change in y-axis by change in x-axis. Here we have taken change in V by change in I. So this one you can calculate R, resistance of a conductor. And if you make it in y-axis, if you put current, and here you in x-axis if you plot potential difference, then if you calculate slope, you will get a inverse of resistance, that is conductance. So that is also there. In short, I will just show you with a small graph. Suppose if I write here V, if I write I, then the slope which you will find, that is change in current, that is, and change in V. So here you will get 1 by R is equals to change in I by change in V, and this is called conductance. Reciprocal conductance is equals to change in I by change in V. This you have to remember. For resistance, its unit is ohm, omega, and for conductance, resistance is per ohm. These two things also you can keep in mind. Okay, so thank you for watching this video. This was a short video talking about the basics, current and Ohm's law, potential and potential difference. Thank you once again.